All right, chapter 2, assembling a computer. Last chapter, we saw how to disassemble a computer, right? That was a very small portion of that chapter. This whole chapter is dedicated to assembling a computer. There's going to be a lot of videos in this chapter and discussing the various ways to assemble it. Yeah. I'll share it with you. Yeah. So we're going to go into a lot of details about assembling a computer, and we're going to learn a little bit more knowledge. So we're going to watch a lot of videos. However, on Monday, we're reporting to the compound, and we're going to go into the lab, and we're going to disassemble and assemble computers. So that's when you're actually going to be able to get your hands on a computer, the parts, take them apart, put them together, etc. So pay attention. You're going to be doing all this on Monday, and you're going to be tested on it later on as well. Easy day?
Easy day.
Awesome. Now the first video we're going to watch is on fire safety, which should be pretty boring, I assume, for all of you, because you've gone through, you're trained firefighters, right? Yeah. So this should be, hopefully, review.
Hello everyone, it's time to talk safety. Let's go over some guidelines in order to avoid cuts, burns, electrical shock, and damage to your eyesight. To start off, we want to remove any watches or jewelry, and also secure our loose clothing.
Why do we want to do that? Right here.
Because of the possibility of like shocking yourself. Like it's just for the protection of the
Shocking ourselves or
I can't think of the word.
the computer, right? Because how many volts can damage a computer?
30.
30. Very good. Now there's other reasons, right?
Maybe your watch or whatever gets caught up in with some of the circuits, you cut yourself accidentally.
You cut yourself accidentally, and we remove our rings and all of our jewelry. In boot camp, I imagine you've seen some degloving videos where all the skins come off. So silicone rings, a lot of individuals in our industry, right, they wear silicone rings, right, just in case they forget, it lowers that risk. However, for us, safety is an automatic failure at things on tests, right? So we're just going to remove everything, right? Earrings, well, guys, that's not an issue, but rings, watches, etc. When we're in the compound, what you're going to do is you're just going to place your badge right next to you. Easy day?
Easy day.
I think I saw it in a hand. Degloving. Oh, that's what you're going to say, right? Very unfortunate and nasty thing that we don't want to happen. Booyah?
Yeah.
All right.
Done. We also need to make sure that we turn off and unplug any equipment before we work on it. A safe and usable workstation is going to be a clean workstation, so make sure you keep food and drinks and any clutter out of our workspace. We also need to make sure that as we work inside of a computer case, that any sharp objects should be covered with tape.
What kind of tape is that right there?
Electrical tape.
Electrical tape. So why? Well, obviously we're covering sharp edges to protect ourselves from cuts, but why are we using electrical tape in this situation?
Things are hot.
And things can get hot, and it's insulated. Very good. Is that what you're going to say?
Yeah.
For your own safety, you should never open a power supply or a monitor that has a built-in power supply.
And we're not going to open up our power supplies. Now, we've seen the capacitors on the motherboard, right? That hold the charges and move the electricity. In a power supply, those capacitors are much larger, right? You don't want to open it up because it can hold that charge and get very hurt if that was the situation.
And while we work, it's very important to wear safety goggles to prevent damage to your eyesight. When you go to lift those heavy computer towers, printers, servers, and more, make sure that you bend your knees when you lift heavy objects. And wait.
All right, that is a great point, right? Any parents in here? Right? You probably have bad backs, right? Your back's hurt, right? You're just used to, oh, let me just do the quicker thing and just lift with my back, right? Is that good to do? No, just think of always doing squats. Who wants to demonstrate the proper way to lift an object for us?
Johnson Brown
Grace say do.
Demonstrate.
Grace wants to show how to. Go ahead, Grace.
Coming up.
Johnson Brown 50.
All right, first demonstrate the improper way in your back, right? Face, come up here so everybody can see you. And face that way. Yeah, just face that way. All right, so first we're going to see the improper way. All right, and now the proper way is, look at that, right? Bending the knees, keeping the back straight. Everybody good? All right, easy. Round of applause.
As we work with electrical and dangerous components, you never know when something might catch fire. You should always know where the closest fire extinguisher is, and also how to use it. As we discuss fire safety, it's important that you remember to never fight a fire that is out of control or not contained. You should make sure that you know how to get out of the building quickly that you are in. And don't forget to contact emergency services for help. Make sure you're prepared. You should locate and read the instructions on any fire extinguisher near your workspace before you use them. Also, you should make sure that the fire extinguisher is going to work. For example, this fire extinguisher no longer is ready to work. It needs a recharge. Now, a fire can spread very quickly and also be very costly. You should know the basics of using a fire extinguisher to prevent a small fire from getting out of control. The word you have to remember is pass. P.
Anyone remember? Do we already know pass?
Hold the pin.
E stands for hold the pin. A stands for aim at the base of the fire, not at the flames. S stands for squeeze the lever. S stands for sweep the nozzle from side to side.
Alright, so we need to know this, right? Pass. P stands for
Hold the pin.
hold the pin. A.
Aim at the base of the fire.
Aim at the base of the fire. S.
Squeeze the lever.
Squeeze the lever. And S. Sweep the nozzle from side to side, right? So squeeze the lever and then sweep the nozzle. Alright, so everybody, P stands for
Hold the pin.
A.
Aim at the base of fire.
S.
Squeeze the lever.
S.
Sweep from side to side.
And nozzle. Again, P.
Hold the pin.
A.
Aim at the base of fire.
S.
Squeeze the lever.
S.
Sweep the nozzle side to side.
P.
Hold the pin.
A.
Aim at the base of fire.
S.
Squeeze the lever.
S.
Sweep from side to side.
Easy day.
Easy day.
Oh yeah.
You should be familiar with the different types of fire extinguishers. Some fire extinguishers, they're actually designed for paper, wood, plastics, and cardboard, while others are designed for electrical equipment or even gasoline or combustible metals. This fire extinguisher here is rated for a couple items. It's rated for trash, wood, and paper. It's rated for liquids, grease, and it's rated for electrical. Let's take a look at my fire extinguisher in action.
What's he doing first?
Hold the lever.
What's he doing there?
Aim at the base of fire.
What did he do already?
Squeeze the lever.
And now?
Sweep from side to side.
Yeah, round of applause. Fantastic. Any questions? All right, now let's get into more IT stuff. Let's look at how to install a power supply. Now these you can probably only orient one way into the case because the outside needs to connect to commercial power, which is what type of power? AC, and the power supply converts it to
DC.
Hello everyone, we've got our PC desktop tower here. We're going to open this thing up and get started in the installation of a power supply. I've got my anti-static mat down and I've got my anti-static wrist strap connected to it, so we're going to be good to go to get started. So, I'm going to take this computer tower and we're going to place it on its face. Put it face side down. And by doing this, what we're going to see here on the back is going to be this huge slot. This is our power supply slot. Now, right now we've got nothing there, so this is where we're going to install our power supply, which we have ready for us, sitting on our mat. To start, step one is to open the right side cover of the computer case. So I'll put this thing back down on its right side, and I'm going to use my torque screwdriver to unscrew this screw holding on this computer case. I'll slide off the cover, and we'll be able to take a look at the inside of our computer tower. Now, at this point in time, we have an empty computer tower. We have nothing installed at the moment. All we have are some USB and audio headers attached to the front of the case. If I put the case front side down, we can view these adapter card slots here right above the power supply slot on the back. Our power supply unit, known as a PSU, that's what we're about to install. So let's chat about the PSU. Now, right now with this PSU,
What's PSU stand for?
it's got so many watts. This is a 450 watt power supply. And on this PSU, it is currently set to 115 volts, the US standard.
Does anyone know what the standard is in other countries?
75.
220.
220. So this power supply unit here, or PSU, has what's called a dual voltage selector switch. So you can select between 115 and 220, right? So you can buy or manufacture one power supply, and you can ship it all over the world depending on what it is. But as the consumer, you need to have it selected correctly, right? What could happen, do you hypothesize, if this was put to the wrong country? It could fry it, right? Which could be an electrical hazard, etc. Now there should be safety mechanisms in place, right? But you always want to reduce that risk. So as an IT, right, you could be installing these. You never know where it's coming, what it's selected from. So you want to reduce that risk. Safety mechanisms exist, but you want to make sure that doesn't happen.
If you look closely at the PSU, we can actually take a look at more details of it, including form factor for the PSU. But that's not for us at this moment. Now, for us, make sure you plan ahead and choose the correct power supply unit for your computer build, especially if your CPU and choice of graphics cards are going to pull a lot of power.
So there are calculators out there, right? Depending on how many components you have, what the power requirement or usage for each of those components are. So you can go out to various websites. I believe Newegg has a tool and some other sites, and you can select all the hardware in your computer, and it's going to say what requirements you need, what wattage your computer power supply needs, and it can recommend those as well. Does that make sense to everyone?
Yes.
Now, when you're doing that, you also want to plan for potential expansion, right? You don't want to just meet the minimum requirements. You want to plan for excess, right? Oh, if I install an additional component, so leave room to add more.
Now, step 2, we need to align the screw holes of our power supply with this power supply slot. So we have the power supply slot here. I'm going to take my power supply and put it into play. And we can take a look at those screw holes that are about to line up and see if we can lock this in. Now my case is really cool because it actually has a locking mechanism that I can let go of the power supply. My screw holes are aligned and it is currently locked into place. Now we need to take the action of screwing it in. If you look closely, you'll see those screw holes are currently lined up, and we can even get a closer view based off of my camera. There we go. So what we want to do now is lock those screws into play. So I'll take 4 of my power supply screws, and we get to put this thing in and be done. All 4 screws are installed. The power supply is not going anywhere. Hopefully you chose the correct wattage for your internal parts. Otherwise you'll be switching this thing out in the very near future. Thanks for watching our power supply install.
All right, let's see what we already know. So let's take a second. We're going to put these into the correct order. So which option is step number 1?
Open the computer case.
Open the computer case. What is step 2?
Align the screw holes with power supply mount.
And finally, step 3?
Screw the power supply into place.
supply, or PSU, converts what to what? AC to DC. What are the three common voltages of those wires coming out of the PSU?
3.5 and 12.
3.3, 5, and 12. Very good. All right, selecting the case and the fan. So everything we know has to fit into the case. It has to fit into the tower. So you want to make sure when you're doing your design, right, that the motherboard fits, because everything connects to the motherboard. If it doesn't, the motherboard doesn't fit in the case, nothing else is going to fit, right? You've got to look at all of your power requirements. Make sure you buy a power supply unit that's going to meet those requirements, and then of course that fits into the case, right? So you've got to do some planning for your fans. How much heat is going to be generated? You want to design it right so cool air is drawn in. That air is going to be warmed up by the components, and then that warm air is pushed out. You don't want to put two fans next to each other, right? Draw the cool air in, push the warm air out. Well, then the warm air is being pushed out and drawn right back in, right? So you want to kind of have it be linear across. Easy day? Easy day. All right, other things you can look at, right, is we know the different form factors of motherboards, power supplies, etc. So that terminology is going to be used. That motherboard is a big determining factor of what case you can use. It can fit into it with its size. And of course, the more room you have within your case for more airflow, the better. Think of a compact tower. The components will be more tightly packed in there, so there's less air to be moved through the device. So the more airflow, the better, right? Because then you can draw in more cool air and push that warm air out. We talked about the power supply. Of course, it's got to fit, and it has to power all of those components. And it has to be able to connect to the motherboard. How many pins does a motherboard connector usually have? 20, 24. And the most important thing, appearance. How does it look, right? It's got to have those fancy lights and look cool, right?
Management.
Probably not, right? But for the user, right, the appearance may mean something. You could have a status display, right? Go ahead and look at the front of your computer cases, your towers now. Notice that there are some lights, obviously for the power, but also for the drive activity, right? Is the hard drive operating? Also, there's one for the network, right? Is there network activity? These vary based off cases as well, and we'll look at that closer later. And the vents for the airflow is important as well, which we talked about. Now, you could buy a computer with a pre-installed power supply unit, but if you're buying that and then, oh, I'm also going to buy this really fancy GPU. Well, now, does that power supply that came with it, is that enough to supply power for that? Something you're going to have to think about. And for us, right, we've got to get away from the mindset of, I'm an IT, playing video games, and what can I use this for in my home life? But what is the admiral or the captain going to need? Or, oh, I may be in charge of purchasing 1,000 computers, right? What is going to be taken into account? Or eventually maybe a civilian, right? What's our budget? What's our specific needs, right? So we got to start going away from thinking about ourselves, playing video games, but as a commercial IT, and what do we need to plan, budget, and design for? Does that make sense to everybody?
Yes.
All right. Choosing a case fan. Think about the size, right? Larger fan generally creates more airflow. That's also going to probably create more noise. Also, the speed of the fan. The faster it runs, the faster it's going to move air through. How many components do you have? So how many fans do you need? What's your physical environment? Are you operating in an air-conditioned environment like here? Or are you prepping to build computers for a team that's going operational overseas in Iran or in the desert somewhere, right? Where probably a lot of heat, right? Think about that. Where are you working out of? Are these going mobile? Are these in a tent in the desert? Or are they in air conditioned? And what are they being used for? But also with that case, where are the fans going to be mounted, right? Think about that. The case is going to have places to mount these fans. So you've got to look, okay, what are my requirements? Is this case going to meet the requirement for the fans that I need? But also, right, those fans need to be powered. Will I have the electrical components? Does that power supply have enough cables or that motherboard? Easy day? All right. Selecting a power supply, we've already talked about that. A power supply converts what to what?
AC to DC.
AC to DC. The three most common voltages are
3.35, 12.
3.35 and 12. And I believe we've talked about all this already, right? The main thing for the power supply unit, the motherboard. The motherboard power supply connector is usually how many pins?
20 to 24.
20 and 24. We talked about the calculators, right? To determine if you have enough wattage to power everything. How many components? What type of components? Because we know about different connectors, right? SATA, Molex, Bird, etc. My internal components, what do they need to be connected to? Does the power supply unit have those connectors? Does it have enough of them, etc.? And will it fit into the case? Any questions?
We're going to install a CPU, Central Processing Unit, into our motherboard. Here's an exercise that is not commonly done in the classroom. We're going to take a CPU, like this chip here, and we're going to install it into our motherboard slot. Now, what we must do is orient the CPU. Step 1 is locating pin 1. Pin 1 is usually what indicates how the CPU orientation should work. We have a triangle, which we'll be able to see right here. We zoom in. And this triangle is what's going to inform us of the alignment of pin 1. Now, if we go to our motherboard and we open up our motherboard slot, if we look closely, what we'll be able to see here as well is that same triangle marking. And the triangle marking is right here, which shows us the orientation for our CPU. Now, our CPU also has a keyed slot on it, and on the CPU on the motherboard housing, you'll also be able to see here that we'll be dropping the CPU, and there's keyed slots to ensure that it's correctly aligned. Now that we know how it should be aligned, step 2 is to safely lower the CPU into the CPU slot. For step 3, we can lower the CPU housing and lock the lever into place to hold our CPU firmly.
Did anyone catch what the form factor of that CPU was?
It is a LGA.
Heard some PGA, some LGA. What's the difference? PGA, where are the pins?
They're on
On the processor. PGA is inserted using zero insertion force. LGA, the pins are on the socket, right? Let's take what we know already and see if we can deduce what it is. Is he installing this using zero insertion force? No, right? It's got that latch, right? That's applying a significant amount of pressure. So this would be LGA. If we rewind, right? Let's look at that CPU.
Pins stick up. You got that?
Here we can see the pins, right? Are on the socket.
Safely lower the CPU into the CPU slot.
And here we can see that arrow. Remember that arrow we were talking about earlier? And there's that arrow that indicates pin 1.
For step 3, we can lower the CPU housing and lock the lever into place to hold our CPU firmly in place. For step 4, it is important that we take some thermal paste and we're going to place a pea-sized drop carefully on the top center of our CPU. This thermal paste will help the distribution of heat from the CPU to the heatsink that we will install next.
Okay, let's talk about that. So this is thermal paste, also known as thermal compound. There's two things, right? It works as an adhesive, but more importantly, it works to dissipate or get rid of that heat, right? Now, the CPU, we already know, produces the most heat in a computer, right? Well, look at that component up there, right? That entire metal surface is going to be producing heat, right? So the way he put that paste on there, right, just in the center, you may think, right, when he applies it, right, that maybe it would spread out. But when you're installing this, you really want to make sure that this thermal paste, thermal compound, is covering the entire surface area of the CPU. Does that make sense to everyone? Why? Because you don't want to have one area be hotter than other areas, right? You're doing something to help out and to get rid of that heat. So do the best you can, right? And ensure the entire surface is covered. Now you don't want to just dump a whole bunch on and have it leak over, right? So still be careful, but make sure that entire surface is covered. Easy day?
Now to keep this CPU cool and prevent it from overheating, we are going to install a heatsink for step 5. These commonly have a fan attached to them, but not all of them do. These fins we see here are going to absorb the heat from the CPU and have slots for airflow to move in between. The fan on top of the heatsink will help draw the heat away and cool the fins. This will allow them to absorb more heat from the CPU. As we attempt to place the heatsink on the motherboard, it may take 1 to 2 attempts to position it correctly over the screws that are going to surround our CPU. The final step, step 6, is to screw down the heatsink. After positioning the heatsink correctly so that it aligns with the heatsink screws on the motherboard, we will screw in the 4 screws in a specific order. It is best to screw one corner first and then go to the opposite corner diagonally from it. This will help ensure we have a flush connection between the CPU and thermal paste and the heatsink. As I mentioned, we'll go diagonally across to the other corner. Now we can continue on the last 2 screws. Now that all 4 screws are locked in, the heatsink will not be able to move or shift at all. Having a tight and flush fitting will also allow the CPU to better stay cool. Thanks for watching our CPU install.
That was a lot going on
We're going to install a CPU.
in that video, right? And that's because the CPU produces the most heat, right? So of course it's going to have a lot of things, right? So let's look again at what we were installing there. We have the motherboard, right? I try to build a burger here for the example. That's the bottom bun. We have the CPU, that's the patty, thermal paste, thermal compound, whatever your condiments are. The heat sink, right? Remember those more blades, helps dissipate. What goes on top of that heat sink?
Fan.
The fan, specifically that CPU fan here. That helps me remember the order that it needs to go on, right? Motherboard, CPU, thermal paste, thermal compound, heat sink, CPU fan, right? Easy day? All right, now let's figure out if it's active or passive cooling for each of these components. So thermal paste, thermal compound, what would that be?
Passive.
Passive. Heat sink. Passive. And the CPU fan?
Active.
Active. Very good. Does everyone remember why? Right? If it's active, it has what? Electricity, right? Something is powering it. Easy day? All right. I see some people writing down this burger. Give you a second for that. Does anyone want to scroll for me? Yeah, you want to help me out? You can bring it up. Oh. Yeah, so the heat sink, right? All that is a piece of metal. But it's a bunch of like small pieces of metal attached to each other, right? There's no electricity with that, but it dissipates heat, right? Because the more surface area, it draws that heat away from the heat source and helps spread it out. Yeah, go ahead.
So quick little thing about the processor. When you guys are screwing in the fan, right? They mentioned the star method, right? But, a good idea is to not tighten every screw down all the way immediately. Right? What you might find is you might be slightly out of alignment. Also, if you get to that last screw and you're out of alignment and you're trying to torque it down, you might actually break what your the motherboard actually. So make sure to about 45% or sorry 75% down all the way across, and then tighten them down just enough. That way you don't break your components.
You definitely don't want to break that motherboard. However, for us, we're not going to be disassembling any of this. We're not going to take any of this apart, right? Because we have right now what, about 1,000 students, right? And every year, right, we would break more components, and it'd be very difficult. So we're not going to take any of this stuff out, right? You're going to leave that CPU fan, the heat sink, the CPU all in there, and you're not going to remove the motherboard either. Easy day? All right, so that's a lot of steps. Let's see what is step one for installing the CPU. So again, what is step one? Orient the CPU in the CPU socket. Remember, we have that triangle to indicate to us pin one. Very good. And step two is?
Place the CPU in the CPU socket.
Oh, I heard lock the CPU in place. Place, all right. Step three.
Lock the CPU.
Lock the CPU in place. 4. Apply thermal paste, IE thermal compound. 5.
Install the heatsink.
Install the heatsink. And finally 6.
Secure the heatsink.
Very good. Close. 100%. Very good. All right, we'll scroll down. All right.
Hello everyone. At this point in time, we have our power supply installed in our case. We also have our heatsink installed on top of our CPU, which is locked into the motherboard. Now, before we move this entire setup into our computer case, we will install the RAM modules. These are the RAM modules. It is much easier to install these now than after we have this entire setup screwed into the case. On our motherboard, we have 2 slots to add RAM. Take note of where the notches are on the RAM slots on our motherboard. Right here and right here. These notches will line up with the notches on our RAM. Step 1 is to open the levers on the RAM slots of the motherboard. We're going to open them as far as they will go. You're going to click into place. This should require almost no force.
All right, go ahead and rewind 10 seconds for me. All right, so installing the RAM. This is the most commonly missed thing, or what people struggle with the most. That's when you're installing that RAM, right? And we'll pass around the motherboard and the RAM so you can practice. You want to use 2 hands or 2 fingers, right? Don't just push down in the middle. You want to apply equal pressure on both sides. Now, normally when you install things, you don't want to apply too much pressure. However, for these, it's going to take a little bit more pressure than you're used to. However, before you do that, you want to make sure that that slot lines up, because this is key, right? So if you're applying pressure, it's not working, right? You don't want to break something. Make sure that it's oriented the correct way. So I'm going to pass around the motherboard, practice, practice, practice. We'll go to the lab and we'll practice as well. Other things, right? You're going to hear that click. You be quiet and then hear that click. Also the notches on the side, right? When it's fully installed, those notches will be flush, lined up. If not, when I'm coming around and checking, I'll know something's missing because I can quickly just see that your notches are either slightly or all the way out like this, meaning it's either oriented incorrectly, right? And you applied, it wouldn't go in, or you didn't apply enough pressure and it was installed. Does that make sense to everyone?
Yes.
Awesome. We'll pass this around so you can practice some more.
One is to open the levers on the RAM slots of the motherboard. We're going to open them as far as they will go. You're going to click into place. This should require almost no force. Step 2 is we're going to line up the RAM module in the correct direction for the slot at that notch. Step 3, we're going to slowly lower the RAM module into the slot. Step 4, now use your thumbs to press down on both sides of the RAM module, and you feel the RAM module be locked in by the 2 lever arms on the motherboard.
Do we hear those clicks?
Next, we take the second RAM module. We'll verify the alignment again, based on the notches on the motherboard RAM slot, and we'll press the RAM module down vertically using both of our thumbs again. Give it a push downward using your thumb on the left and on the right. As it clicks in, now the RAM modules are installed. This is exciting. Proceed onward in the course. We're almost ready to put this motherboard into the computer case.
All right, let's see what we know. What is step number 1? Open the RAM slot levers. And step 2. One more down. D.
Delta.
There you go. Perfect. Step number 3. And step 4. Very good. We'll hit submit. Another 100%.
Gotta run a record.
Right. Let me make sure we're not missing anything before we continue. All right, when we were installing the CPU, what's something you definitely need to be wearing when you're installing the CPU? Anti-static wrist strap. Having it working on an anti-static mat would be good as well. All right, let's watch this next video.
Hello everyone, can you believe it? We're going to install the motherboard with the CPU, heatsink, and RAM into our computer case. Before we just place the motherboard into the computer case and call it a day, we first need to install the standoffs into our computer case. These standoffs will be used to secure the motherboard in place within the computer case. Some computer cases will have built-in standoffs, like mine for example. Others, you'll have to take a standoff and install it yourself. These standoffs are commonly small, and you'll screw it in using an adapter that comes with the standoffs. In order to locate the standoff location,
Those standoffs, they can either be metal or they can be plastic as well. You get, okay.
comes with the standoffs. In order to locate the standoff locations, it is best to take your motherboard and practice placing it into your computer case. Step 1 is to align the motherboard in the correct direction by having our adapter ports facing on the back of the computer case. So we'll take our motherboard. The motherboard is resting in the case. Step 2 is to locate the exact standoffs that are needed by looking at the screw hole locations. You take a close look at it, you can shift the motherboard, and we'll be able to find the exact screw hole locations that'll be needed. Step 3 is to remove the motherboard and then screw in the standoffs at the correct locations. Since my computer case does not require this step, we're going to continue on. Assuming you've installed your standoffs, step 4 is to take our I/O plate, input-output adapter plate, and align it on the back of our computer case. This will provide adequate dust and airflow for our computer case. Let's position the I/O adapter plate with the writing ports in the correct direction. If you install the I/O adapter plate upside down, the motherboard won't be able to fit correctly. So make sure that it's correct. As you put the plate into place, give it a push in each corner and along the edges, and you'll hear it snap into place. Take your time on this step, as some adapter plates are plastic, while others are metal. They are possible to bend and or break. Now that the plate is installed, put the computer case back on its side for step 5, lowering the motherboard into place. Let's finish installing the motherboard. The key of installing the motherboard is to put it into the case at the correct angle. As we place it in, we need to align the I/O ports of the motherboard with the slots of the I/O plate. if I pick up the case, we should be able to see it resting nicely. At this time, we can use our screwdriver for step 6, installing the screws into the motherboard standoffs. One by one, we will install the motherboard screws. Make sure not to install the screws too tight, as you don't want to crack the motherboard through excessive force. Don't worry about the screws being not overly tightened, as we have a good amount of screws to keep this motherboard in place. If you choose to upgrade your CPU or heatsink in the future, some gaming and high-performance heatsinks actually require you to remove the motherboard and install a special plate to the back. Let's get started installing those screws. Now that all the screws are tightened, we are good to finish our build and continue on to the next video. Who knows? You might be removing your motherboard and installing it again in the future. Get your practice with us here for installing a motherboard into a computer case.
All right, let's all stand up. There's a lot of videos in this lesson, right? So let's just quick stand up, shake it out, right? Get the blood flowing, right? When you feel good, sit back down. But feel free to stand up while we do this next activity. There's a lot of steps. There's 6 steps for installing the motherboard. To give you some time, right? So stand up, shake it off, look at all these options as we try to figure out the correct order to install a motherboard. All right, are we ready for the first one? All right, what is step 1 for installing a motherboard?
Locate the standoff.
I heard locate the standoffs, and I heard align the I/O plate.
Locate the standoff.
Locate the standoff.
All right, locate the standoffs win. Let's go with that. What is step 2?
Line.
I heard install the standoffs. And these standoffs can be either metal or plastic. What is step number 3? I heard align the I/O plate.
No.
But I heard a no. We need to go back.
Standoffs. I thought the standoffs was first.
All right, let's go. All right, let's do this.
Oh yeah, no, it's the motherboard. But the plate.
All right, what do we think step 3 is?
I think it's a line.
I'm still hearing align the I/O plate. Let's go with that.
It's align the motherboard, then the plate.
No.
No, it's the plate first and then the motherboard. But he didn't put the motherboard in before you
Don't put it upside down. The video is different because you said there's a
Should we watch the video again?
No.
All right, let's do this. Raise your hand for motherboard. For align the motherboard. Raise your hand for align the I/O, input output plate. The I/O plate wins. We're going to go with that, and we'll find out, all right? What is step number 4? Align the motherboard now we want to go with?
Yeah.
Yep.
Okay. What is step 5?
Motherboard into place.
Wait, what?
Yes.
That don't make no sense. Align.
Yeah.
It's in
You
the
align it and
You
then
align
lower
it
it
and you lower it in.
Align it, lower it. That's correct.
All right, so do we want lower the motherboard first or align the motherboard first? Raise your hand for lower. Raise your hand for align.
It's lower.
All right, so we'll do align first and then lower. All right, so step 6
How do you align it if you don't?
is install the screws. All right, let's hit submit and see what
It's
happens.
gonna be wrong. It's wrong.
Go ahead and hit reset. All right. Maybe shaking it out, standing up didn't work so well. That's all
I
right.
think you made it shake it out too much.
Too much shaking it off. Taylor Swift. What is step 1?
It's definitely locate standoff. It's
It's low key standoff.
No,
All right, let's try this. Let's try this. This side of the room, you get the next attempt. If you don't get it right, then we'll go for this side. That work for everybody?
Yeah.
All right, so this side, what's step 1?
Locate the standoffs.
Locate the standoffs. Step 2. You're good for step 1. Step 2 is
Install standoffs in the computer case.
install the standoffs I'm hearing. What is step 3? Heard someone say lower the motherboard.
It's align the IO.
Align the IO port they want next.
Yeah.
I know, but he aligned it.
What do you want for 4?
Install the screws.
Lower the motherboard, I hear they're saying.
See how the put
5. Six. All right, this is what you want this side? All right, hit submit.
You really have to finish with the stand.
No. All right, other side of the room, your turn.
Alright,
What's step 1?
Align the motherboard in the correct direction.
Where'd y'all start?
No, because you have to align the motherboard to know where the standoffs go. You align the motherboard first. E1.
We're in shambles, bro.
Wait, no, it is okay. It's still 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 okay. I'm lying.
All right, sounds like they want to locate the standoffs.
And then you locate and align the motherboard. And then you install the standoff. You have to align it. You have to find the standoff first, and then you align it. You align it so you know where the standoff goes. Exactly. What?
Is that what you want for step 2? Install standoffs they want for 2. That's majority wins. 3.
If it's not aligned, bro.
What do you want for 3?
So you have to align the motherboard.
How are you gonna put the motherboard in if the standoffs already in?
Locate your standoff.
Remember, the motherboard is installed on top of the standoffs. What do you want for 3? Align you want?
Yes, but you have to align. You really put the motherboard in the tone
Go ahead and scroll up.
to find where the proper things were.
Replay the video.
Alright, listen up.
Align in the correct direction at step 1.
Hello. Can you believe it? We're going to install the motherboard with CPU, heatsink, and RAM into our computer case. Before we just place the motherboard into the computer case and call it a day, we first need to install the standoffs into our computer case. These standoffs will be used to secure the motherboard in place within the computer case. Some computer cases will have built-in standoffs, like mine for example. Others, you'll have to take a standoff and install it yourself. These standoffs are commonly small, and you'll screw it in using an adapter that comes with the standoffs. In order to locate the standoff locations, it is best to take your motherboard and practice placing it into your computer case. Step 1 is to align the motherboard in the correct direction by having our adapter ports facing out the back of the computer case. So we'll take our motherboard. The motherboard is resting in the case. Step 2 is to locate the exact standoffs that are needed by looking at the screw hole locations. Take a close look at it and shift the motherboard, and we'll be able to find the exact screw hole locations that will be needed. Step 3 is to remove the motherboard and then screw in the standoffs at the correct locations. Since my computer case does not require this step, we're going to continue on. Assuming you've installed your standoffs, step 4 is to take our I/O plate, input-output adapter plate, and align it on the back of our computer case. This will provide adequate dust and airflow for our computer case. Let's position the I/O adapter plate with the writing ports in the correct direction. If you install the I/O adapter plate upside down, the motherboard won't be able to fit correctly. So make sure that it's correct. As you put the plate into place, give it a push in each corner and along the edges, and you'll hear it snap into place. Take your time on this step, as some adapter plates are plastic, while others are metal. They are possible to bend and or break. Now that the plate is installed, put the computer case back on its side for step 5, lowering the motherboard into place. That's finished installing the motherboard. The key of installing the motherboard is to put it into the case at the correct angle. As we place it in, we need to align the I/O ports of the motherboard with the slots of the idle plate. If I pick up the case, we should be able to see it resting nicely. At this time, we can use our screwdriver for step 6, installing the screws into the motherboard standoffs. One by one, we will install the motherboard screws. Make sure not to install the screws too tight, as you don't want to crack the motherboard through excessive force. Don't worry about the screws being not overly tightened, as we have a good amount of screws to keep this motherboard in place. If you choose to upgrade your CPU or heatsink in the future, some gaming and high-performance heatsinks actually require you remove the motherboard and install special plate to the back. Let's get started installing those screws.
All right. So I think we learned a lesson here, right? Seems pretty easy, right? Watch videos. Okay, yeah, that makes sense. That makes sense, right? But sometimes even getting into our memory, our short-term memory, we're not maybe paying attention to the right things, right? So keep that in mind, right? That's simple. Am I spacing out, right? So let's go ahead and revisit this. We think we got it now?
Yeah.
All right. Step 1
Align
is
the motherboard in the correct direction.
Step 2
Locate the
is Step 3.
Install standoffs.
Step 4.
Align I/O plate.
I think I'm hearing align the I/O plate. Is that right?
Yeah. Yeah.
All right. Step 5.
Lower the motherboard.
Lower the motherboard into place. And finally, step 6.
Install the screws.
There you go. We'll hit submit. So much easier that time, right? So just keep that in mind, right? Studying, etc., etc. Do we need a quick break? Yeah. All right, let's take a 15-minute break. Our next section, 2137, selecting a motherboard. The motherboard we consider to be what component? Backbone. The brain is the CPU. Very good. So when we're selecting a motherboard, what are some things you think that we really need to think about when choosing a motherboard? The form factor, the shape and size, right? Like, is it ATX, ITX, etc.? The CPU, right? The socket's got to be the same as the CPU. Is it PGA or LGA? Is that what you're going to say? Yeah. All right, what else? The expansion slots, right? Do my adapter cards, do they fit in there? Anything else? RAM, right? Does that RAM slot? How much RAM do I need? The case. Well, let's fill it into the case, of course.
Power supply, the actual amount of power you need to supply.
Power supply, right? Because it's got to be able to power that motherboard and all the other components as well. Booyah? Yeah. All right, now when we think back to a motherboard, the electricity and data flows through it somehow. How does it do that? What's that called?
Bus.
The buses, right? Now there are two types of buses. We've got data bus and we have an address bus. All right, so the data bus, right, that's the data, where the data is going to go through for the data buses. And then you have the address buses. Those are for the memory location. That's going to be used for the CPU to know, okay, where am I doing this? How do I do that? So there's two types of buses.
Repeat that one more time.
The address bus has the memory address, the location. So the data is the data, right, the information. And the address portion, that's the location of where the CPU is going to read and write that data.
So is it kind of like the data bus would be like the streets to get home, and then the address would be like the actual home?
Think about it as the address, as how the CPU is going to do it, and the data is the actual information. Does that work? Yeah. So for your analogy, I don't know how to make that work. So maybe,
That's kind of weird now.
yeah. I'll see if I can think of another one. Yeah.
Will we have access to the recordings of the classes?
Do y'all want the recordings? I'll put that out at the end of the day. That work for everybody?
Yes.
Okay. Yeah.
The location where the CPU.
Yeah. So for the read and write, how the CPU is going to locate that. Yeah, I'll share the screen. Go ahead and escape for me.
We have one question in the back, I think.
Thank you.
You have a question back there?
I was just going to ask if we could have access to the screen, but we are.
Already done. Good to go. All right. That's a great point, right? If I forget to push my screens to you, definitely let me know as soon as possible. Mr. Novak, we need the screens.
I was talking about our screen.
Oh, you want your screen back?
That would
Yes.
be nice.
Yeah? Does everybody want their screens back?
Yeah.
Let's take a vote. Who wants their screens back? Who wants my screens on their screen? I'm just going to keep it, right? Monday, right? We'll I'll give you your screens back, right? And we can figure out if you want me to push your screen, I'll put you in 2 different groups. Easy day?
Yeah.
All right. Question?
It's gonna be like jumping ahead, but like what defines the difference between like newer motherboards compared to like the one that you do faster, or like what's the thing out like is a big difference?
So that's a good question, right? What's the difference between an older or legacy motherboard and a newer one? And we learned about older form factors and newer ones. So for this course, right, it's that form factor, right, and the speeds, right? There are different bus speeds that we'll get into. It may be the sockets for the RAM. The older motherboards would have older expansion slots like PCI. Newer ones would have probably what expansion slots? PCIe, et cetera, maybe an AGP, et cetera. Does that make sense? Now for real world, right, what's happening now is, like you probably noticed in iPhones and laptops, that it's all custom built now. That all of this stuff is getting shrunk down to one piece and is not too customizable. So we're really getting away from this stuff for commercial or typical users. However, right, for enterprise, like large networks like us, we're going to have these full-size towers. So it's still going to be relevant for you all, right? In the workplace, either civilian or Navy, right? You're going to have these full-size towers, and it's still going to utilize like an ITX, mini ITX, et cetera. That work for you? All right. Any other questions, hands? All right. Moving on. Well, not quite yet. We've alluded to talking about 32-bit versus 64-bit a lot, right? So you've got various things on your computer, hardware and software, that are going to be 32-bit or 64-bit. You've got your CPU, what your RAM can do, etc. This is how much information it can process at a time. We're going to watch a video to see if that can be explained a little bit easier. Go ahead and hit escape. Go to that other tab.
A quick search on our height evaluation machine, also known as the Google, is just shy of 9 million hits, about 64-bit versus 32-bit processors. No. Some of this hype was started by the PC crowd back when AMD launched their first desktop PC 64-bit CPU back in 2003. But since last fall's launch of the iPhone 5S, the first smartphone with a 64-bit CPU, it's become a hot topic again. But what does it actually mean for average Joe? Let's start with what a bit is very briefly here. 1 bit is a single character in binary, either 1 or 0. So we can only express up to 2 values. With 2 bits, we can express up to 4 values, and with 3 bits, that goes up to 8. Every bit we add increases the number of different values we can represent in binary exponentially. Now, you'll hear about bits in relation to all kinds of computer things, from data storage to data transmission to data processing. So that brings us back to CPUs. In the context of a processor, the number of bits generally refers to the amount of memory it can address. So while a 32-bit processor is, without PAE magic tricks, limited to about 4 gigs of memory or RAM, a 64-bit processor can handle up to 16 billion
gigabytes of RAM.
All right, Linus, that sounds interesting. More RAM is good for performance, right? Bring on the bits. Where's my 128-bit? Well, hold on a second there. Cool your rainbows, my pony friend. More RAM is only beneficial if you need it to store data that's applicable to the task your processor is working on at a given time. Adding more RAM to this isn't going to make the ball move faster. So a move to more bits for processors is not something to be undertaken for no reason. Aside from the hardware re-engineering and instruction set architecture extension or redesign, it involves a complete rewrite of fundamental parts of the operating system, be it Windows, OS X, Linux, Android, iOS, or whatever. It requires specific driver software for all hardware components that will be used. And finally, application developers will need to at least recompile and debug their code just to achieve basic compatibility without taking advantage of any performance improvements. Well, okay, Linus, but I really want that shiny new 64-bit processor. Maybe the entire hardware and software industries will cooperate for a fast migration for the first time ever, so I can have huge...
Go back to the other thing. Okay, so that's good right there, because I think he gets a little bit misinformed after that. So we've already kind of talked about, right? If you've got a 32-bit CPU, you can only use a 32-bit operating system and 32-bit applications. If you've got a 64-bit CPU, you can use 32-bit or 64, right? But you can't go back, right? So it is significantly faster and more efficient, right? And really, most things are on 64-bit.
So, so if I had you couldn't run the, say you did have an older model, but you put the 64 in it, would it still run if you run from the 64 and bit like?
So hardware's got to be 64. If your hardware is 64, then you could do 32 software, right? But if your hardware is just 32, you're limited to 32. Does that make sense?
It does, yeah.
Yeah, fantastic. What else we got? Okay, let's do some recap, right? Front row, can you all still see this board up here?
Yes.
Yeah? Yes. All right. I think hopefully we can see what's going on here, right? This is all the components on a motherboard, right? The motherboard is considered the backbone. What is the brain, Jackson? CPU. CPU stands for Central Processing Unit. Everything's trying to get there, right? Before it gets to the CPU, what's it hitting? The North Bridge. Now the North Bridge provides high-speed access to the CPU for what two things? Graphics card. I'll just put GPU up here, and here we got all our RAM slots here. Easy day? Now everything else, the slower speed devices, are going to go through what? South Bridge. Such as what?
Storage.
Storage like our hard disk drives. Solid state hybrid drives. I heard USB ports. BIOS UEFI. I heard keyboard mouse. And then all of these here are our expansion slots. All right, we all remember that? Okay. Now again, how does all of this stuff, how does it move across the motherboard to these different locations? McCants? What's it called, everybody? The bus. Very good. Now there is one bus that's going to be more important than the others. A potential bottleneck. Between what two pieces of hardware do you think the bus is going to be more important? In the back?
CPU and GPU.
Between the CPU and the?
GPU?
Not the GPU. We don't have a direct path there. But the North Bridge, right? That GPU, that video card goes through the North Bridge. So right here, this is what we call the FSB, the front side bus. That's that front side bus. Now that can be 32 or 64 as well. Now the clock speed for these, right, for the CPU and for that front side bus, right, that's for the speed, how often we can process, etc. What usually happens is the clock speed of the CPU versus the front side bus, the CPU is going to be a lot faster, right? So the bottleneck is going to be in that front side bus, not the CPU. So the CPU is not constantly overwhelmed and I can't take anymore. You're just constantly feeding me, right? The bottleneck's going to be here in this front side bus. However, still, right? That front side bus, still very important because so much data and address. Remember, we got the data buses and address buses, right? To get everything to the CPU. Everything's trying to get there. Does this kind of make sense to everyone? How are we feeling? Back row? Good?
What's that box next to the Bible?
Keyboard, mouse.
Yeah.
Keyboard, mouse. I'll rewrite it so it's a little easier. Well, we'll do USB, keyboard. You know, I should have wrote it and then the box. Good in the back? All right, see some people writing. Give you a second. Now we've mentioned it before. There's one piece of hardware that's not on here. Can anyone realize what's not on here? The chipset, right? And who remembers what that chipset does? Right? Because this is all attached to the motherboard. Right? So all of those things between there and the motherboard, right? All of this to the motherboard, that's that chipset. It's managing that. Right here.
Where's the chipset located again?
So it's going to be on the motherboard, right? But in this topology here, this map, right, it sits outside of it because it's managing this and how it interacts with the motherboard that it's on top of. Good?
Yeah.
Okay. But we'd have to 3D this up kind of. Is the motherboard still going around? Good. I just wanted to see where it's at for the next thing. We need more time to write? Yep. Okay. You got time to take notes still? Okay. 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 And you all wanted access to the videos, you said? Think that'd be a good study tool for y'all? Okay. That's me.
Can you like scoot the whiteboard over that way some?
Front row, you all good?
Perfect.
You can see that?
Yes. Thank you.
Do I need to move it more this way? No? Okay. I'm locked in now. I drink coffee before work. Oh.
We're going to do chapter 2 at the end of the weekend.
It's like, you say you can't see it from up high. It's like
You said
you telling me what I said. I'm telling you what he said.
So it's on the motherboard, right? But this is a map of how like the data flows and things like that. So the chipset isn't a part of that, but all this is on the motherboard, right? So how all of this interacts with the motherboard, the chipset is managing that. Oh, I can't see. So those are heat. I believe those are heat sinks. Yeah, those are heat sinks. Yeah, on top of a device. That's probably your south bridge right there. Newer than what we've seen already, but still not too new. Remember that heat dissipation is really important, so your computer can be more efficient and can run faster, because we'll talk about throttling and things.
Yeah, I'm going.
All right, let's move on. All right, let's scroll down. All right, how do you decide what CPU and what CPU cooling to use? Well, different manufacturers typically are going to invest their R&D, their research and development, into one type of form factor. Who remembers what those two form factors are for a CPU? LGA, PGA, they're right there. Which one is inserted using ZIF? PGA. Which one has the pins on the processor? Which one has pins on the socket? LGA. So here we can see Intel typically uses LGA, right? And we can see their different sockets. And AMD typically uses PGA, and we can see all their sockets there. Huya? Question?
Does that say, what is AM4 and AM3? Is that just another way to say?
That's their naming convention.
Okay, that's what they're, okay, because I've heard that.
Yeah, you know how like you've got the iPhone 15, 16, 17. That's how Apple names their devices, right? Samsung, you've got like what, S22, 23. So Intel, right, just uses these, right, 775, 1155. It's like product names to identify what it is and the different capabilities and speeds. All right, scrolling down. Speeds of a CPU are measured in megahertz, but now they're measured in gigahertz, right? They're faster, right? Now, the faster a CPU goes, or the higher frequency, the megahertz or gigahertz, the more heat naturally it's going to create. So you need different cooling. We talked before, right? So what's on a motherboard? Next, we're going to solve the CPU. What goes next?
The
thermal paste, thermal compound, and then the heat sink, and then the CPU fan, right? Now, you may do water cooling if you want to spend that money, and then, but you've got to buy unique components for that as well. So we'll scroll down, and when we're choosing our cooling, we want to think about what socket's being used. Is it PGA or is it LGA? What are my motherboard specific characteristics? Right? Where can I screw in the heatsink, the case fan, etc. for the CPU? If you're doing water cooling, you're going to need a specific motherboard for that, and make sure everything is compatible. There are tools online to make sure everything works, as well as the size of your case. Chief was talking about some cars yesterday, right? You ever seen those cars with the engines poking out the top? Yes. Oh, faster, right? Well, you wouldn't really have a computer where the stuff's poking out the top, right? You don't want to have to remove the metal case and have the fan coming up, because they're built in a certain way to be enclosed, to make sure air comes in one way and is pushed out the other way. Huya? Yeah. Also, your physical environment. Where are you located for how much cooling? Easy day? Yeah. All right, the next section. Choosing memory. What do we call memory? RAM. RAM. Very good. So, of course, we've learned about different types of RAM. DDR2, 3, 4, 5. We learned all those pin counts yesterday, right? Hopefully we're studying those. So they have to be compatible. The socket and the RAM have to be compatible. Now, there are two different types of RAM as well. Can someone give me the RAM module? Where's the motherboard at?
Motherboard's in like just last.
Let me just borrow one module real quick. Thank you. All right, so we have unbuffered memory and buffered memory. So here we have our RAM module here. Now where the memory, the storage is actually located are in these black chips here, right? So for unbuffered memory, that's how it is, right? Each of these are memory locations, right? That's for our storage. Easy day?
Yeah.
Now, the size of RAM is increasing, increasing, increasing. If you're doing a large project, maybe video or CAD, computer-aided design, AI, etc., it's going to use a large amount of memory. So if you do something in a large quantity, you can't just go out and willy-nilly it, right? You want to have something to manage that. And that's what buffered memory is. One of these chips is going to be used for management, right? So it can manage those larger files. Now, because it has an extra chip to go through, it's going to be slower, right? So it's going to be, for those specific things, it's going to be more efficient to do that, but in general, it's going to be slower. So if you're gaming or things like that where you need fast RAM, you would use unbuffered memory. Buffered memory would be for specific things that use that large data sets, large amounts of memory. Does that difference make sense? Questions? Okay, I'll give you this back if you want to try both of them again, so everybody gets a chance to do as much as possible. We need more time to write? All right. So because it has that extra control chip, it's going to be for things that use a lot of RAM, right? So not your you may think video game uses a lot of RAM, and it does, right? But it's small amounts, right? So large amounts of RAM. Think of large computer-aided design files, large possibly SQL databases, AI, etc. Right? They're going to use these. No. AI is the big thing, and he's just going to be talked about more and more and more.
I know you said video games use a smaller amount, but like, what about, just curious, Call of Duty or like GTA, games that have a lot more?
So same thing, right? It's a lot, but the chunks of it are smaller, right? It's a frame, right? So a frame, but very quickly. There's a lot of information in that frame, but what we're talking about is like gigs, like to process this, right? That it takes, it's not just, your video games are very quick, right? You don't want latency, but with these large files, their processing time, right? They're running a program, and it's taken several minutes to several hours where that memory is going to be going through these files. Does that help at all? Okay. You're not playing your game and, oh, I can go get a coffee or use the restroom and then come back. You want it to be fast. Yeah?
Do you think AI would make our job easier or harder?
Both. Easier for operation, possibly more difficult for security. But we got a chapter on security, so once we got a more basic understanding, we'll be able to have more in-depth conversations about that stuff. Yeah, we'll talk about that more later. Good. That way we can get some terms down that you all can possibly understand or get a better grasp of maybe some things. Well, I don't know. I don't know the future. All right, let's scroll down. And some more. And we're going to watch a video.
Hello everyone. In this video we get to install some drives. We're going to focus specifically on a hard disk drive and an optical disk drive. Now first, we have the hard drive. Now this is an adapter. It's not actually a full hard drive. It's a 3.5-inch hard drive adapter. And the reason this is important is because people commonly like to purchase these type of drives. These are solid states. They come in a 2.5-inch side, which is meant for a laptop. With adapters like this, we can easily take a solid state hard drive, drop it into position, and close the lever. As we close it, now the 2.5-inch drive is in a 3.5-inch adapter. With this being done, we could easily just slide this into our computer case and do the install of our screws. Now for my computer case, it accepts both 2.5-inch and 3.5-inch drive, so I don't need to require an adapter for my case. But at this point in time, we can take our 2.5-inch solid state drive and we can install it into our case. When I line it up with the 2 screws, which we'll be able to see there's many different screw holes on the side of these, we need to align it up perfectly with a set of the holes. Now for me, my 2.5-inch hard drive is beautifully right here.
2 things. So first thing, we're not going to screw any hard drives into the computers, right? We already talked about why, because they're in and out all the time. Also, it's not going to be that fine-tuned either. There's trays that these are just going to slide right into, and we'll see that on Monday. Yeah?
Yeah. And then I can do my second screw. And now my 2.5-inch solid state hard drive is installed. After this, we want to install the optical disk drive. First, we need to make sure our front panel of our case has been removed. The front panel of the case, right here. And this is the slot where we're going to install our optical disk drive. Now the first thing we need to do is remove this front panel because it's in the way for us to actually be able to access the optical disk drive. Here we have these levers that we can actually pull out. And every case will be a little bit different. We'll have some type of snaps or levers. And I can remove that front panel. Now with it removed, if I put it on its back again, take a look at that. We have this bay here where we can slide in our optical disk drive. Now, as we slide the optical disk drive in, please make sure it's facing the correct orientation. That is extremely important. We'd hate to have to turn the tower upside down every time we want to use the drive. Now with my case, the drive locks in using a lever mechanism as I slid it in. As you saw previously with the power supply, this will hold it in place, so we then just place our screws to lock it in. Which we'll do now. Awesome. Next, we'll continue on with installing adapter cards to provide our computer tower with even more functionality.
Any questions? All right, when you're selecting a hard drive for a brand new computer, well, what are your uses for that you're going to be using that computer for, right? How fast do you need that hard drive to be? Remember some of the common RPMs for a hard disk drive. 5400, 7200, 10,000, 15,000. And RPM stands for rotations per minute. 10,000, 15,000, really fast, right? In fact, probably almost, not quite, SSDs are the fastest, right? But they're more expensive. When, now, your hard drive might start working slowly. Maybe you're reading your write speed, saving things, moving files, etc. Might start taking longer. Maybe your hard drive is starting to fail or become corrupt. Or maybe your hard drive starts making weird noises. Your hard drive is making weird noises. What type of hard drive do you probably have? Well, think about the categories, right? Do you have a solid state? No, you probably have a hard disk drive, right? Because does solid state have moving parts? No, no moving parts. The HDD has moving parts, right? Awesome, okay. Other things to consider, is your hard drive hot swappable. Well, if you've only got one hard drive or one storage device in your computer, it certainly is not hot swappable because that's where your operating system that we're going to learn about later is stored. Who yeah? But maybe if you got a second hard drive, right? Is it hot swappable? Who remembers what hot swappable means? Bingo, bingo. Easy day? All right. Now the size of your hard drive as well. Who remembers the three sizes that hard disk drives typically come in? 3.5, 2.5, 1.8, right? And same for solid state drives, but those are typically going to be 2.5 and 1.8. Easy day? So of course, right, if you've got a computer, right, and you're replacing, upgrading, right, you want to know, oh, what slot, what's the room for my hard disk drive or my solid state drive? Easy day? All right. And of course, the power requirements. But typically, a storage device is going to be powered with what? SATA. How many pins for power? 15. Very good. Now let's move on to CD drives, which we call optical drives, right? Uses optics, uses lasers, right? And yesterday we learned about, if we scroll down, all of these, right? Remember, we learned about CD-ROM, RW, plus or minus R, all that stuff, right? So if you're probably not remembering it now, make some note cards, quiz each other, etc. Who ya? Yeah. All right. A optical drive, we can see in that picture there. You also want to know, is it a CD optical drive? Is it DVD? Can it do Blu-ray? Etc. Scroll down. Installing a hard drive. We already went over the bay sizes. Now, for an optical drive, that's going to be installed in a 5 1/4 or 5.25 inches. So get that confused with storage, which is going to be, or hard disk drives, which go in where? 3.5, 2.5, 1.8, right? So the bay, right, that these can go in, an optical drive goes in what size bay? 5 1/4, 5.25. That's the size of the slot, the bay that we slide it into. Other storage devices, hard disk drives, solid states, are different. Easy day? All right. Continuing on. Right, we see the screws. We're not doing those. Optical drives, we've seen multiple videos, right? How do we remove an optical drive? The big thing is it comes out of the front. We've got to remove that front panel first. Easy day? So step one, well, we've already seen videos. Easy day? All right, moving on. Moving on. Let's see what we know. These are going to be true or false statements. Optical and drives are installed from the front of the case. True. It is recommended to hand tighten drive mounting screws prior to using a screwdriver. True. So we want to hand tighten prior to using a screwdriver? False? All right. Raise your hand for true. Raise your hand for false.
Not a lot of confidence there.
Not a lot of confidence. Let's come back to it. Modern motherboards provide the IDE ribbon cable interface for internal drive storage. False. What do we use? SATA. Very good. The SATA interface can be used to connect hard disk drives, HDDs, SSDs, solid state drives, and optical drives. True, we know that, right? In installations in which CPU cooling is important, hard disk drives are preferred for storage. False. So what's going to produce more heat? A hard disk drive or solid state? Hard disk. So what produces less heat? Solid state. When installing a HDD or SSD, the connector should face the front of the case. False. We'll see that tomorrow. Or Monday. And what do we want to go back up to? Hand tighten prior to using a screwdriver? True. All right, we'll go with true. We'll scroll down. We'll hit submit. That's right. Very good. Good job. Question? Oh, boy. What does IDE stand for? Integrated Drive Electronics, maybe? Bingo, Integrated Drive Electronics. Still got it.
Glossary, right? Glossary.
Go ahead with that video.
Hello everyone. In this video we do install adapter cards. So first what we want to do is take a look at our case. And we need to take a look at what adapter slots we have. Inside of my case, we take a look at the motherboard and a closer up. We have a PCI Express 16. Then we have 3 PCI Express 1s. So what we want to do is be able to pick out adapter cards that are going to be compatible with these PCI Express slots. Also, if you're wondering what this is a mini PCI Express. Think of wireless cards that you'd be able to install on a desktop topper. So let's get started. Step 1, we're going to need to find an empty slot, which we have right here. So what we need to do is take off the corresponding cover that covers that slot. To remove this cover, which is covering the slot, I just have to lift up my tower, and we'll take a look at what I need to do on the outside. This screw here is holding on to those adapter card slot covers to keep them in place. So I can go ahead and I can unscrew that with my special torque screwdriver. With that screw out, we can actually take this cover, it just lifts off, and that exposes all the adapter card slot covers. At this time, I can actually take out this cover, and just lifts off. I can remove it from the computer case. Now the adapter slot cover is exposed, and we're able to zoom back in and continue on. With that slot cover exposed, we can now install a PCI Express 16 card. I happen to have a PCI Express graphics card. It's a PCI Express 16, which we have here, which is the physical compatibility that matches that slot. Step 2, I'm going to align the video card into the appropriate slot in the motherboard, which will be right there. For step 3, we need to press down gently on this card to install it into place. Step 4, we need to reinstall that slot cover. We'll put my slot cover back on, and we will take our screw on our screwdriver, and we'll screw it back into place. Thank you for watching. Our adapter card is now installed.
All right. Very good. All right, selecting an adapter card. So here now, this is just talking about all of the different adapter cards, which we've already talked about. So for example, if I want to record something from cable, television, etc. to my TV, what would that be? Capture card. Okay, what about to connect to a network? Nick, what if you want to produce a new rap song? A sound card. All right, let's keep going. And we know adapter cards are installed into what? Expansion slots. Expansion slots. And we know about the different types of expansion slots. Which one has different size slots? PCIe, right? Right here, this highlighted is PCI. If you go to the next tab, right, we can see this is a PCI times 1 slot, which is the smallest. And the next one, it goes 4, 8, and then the largest is 16, which we can see up here. Easy day? All right, scrolling down. Other factors to consider, right? Of course, it's got to fit into the right expansion slot, but does it fit into the case as well? Does it meet your needs? What are the power requirements? Maybe it's got a heatsink or a fan on it, which may require additional power, which would be how many pins? 6 to 8. Very good. So we'll click next. Here's a picture of a graphics card. Next, we can see a sound card. Next, we see a storage RAID card or storage controller card, which we'll learn about later. Next, we have an I/O card, which stands for input output, and you can have a variety of these, right? Which all the cables we learned about: DisplayPort, HDMI, USB. Next, we have NIC, which we talked about to connect to a network. It needs to be wired or wireless. And finally, we have our capture card, which we talked about to capture a signal. Ooh, look at that. Yellow, white, and red. What's that? RCA, right? Ooh, I heard you get into the left and right. Which one's video? Yellow. Yellow, very good. We'll scroll down. Now, installing adapter cards. We've seen that in the videos. Now we see these covers right here. If you don't put these covers on, which you'll probably see in the lab, well, then more air can get in, which means what else can get in? Dust, right? Dust is really bad. Not just that, right? Bugs wouldn't be as bad as other things that have gotten in there. Because computers are warm, right? Rodents, snakes, etc. can get in there as well, right? And you can Google photos of that and you can see that's not too fun. All right, question?
So like a lot of those gaming PCs are like, I mean, specifically my roommate, they don't have cases. Like, is the passive like cooling worth those issues? Like, that makes sense? Is that the right question?
I think to the nut.
So they're trying to be more efficient.
They don't have any covers at all. Like everything's like, yeah.
So the board is fully exposed. Like,
Yeah,
it's
exactly.
dangerous to have the board fully exposed.
So basically, their fans aren't really doing much. All right? You want to have it in a controlled environment, so that way it forces warm air in, right, within the fan, over the components, right? The faster, cooler air, right, warmed up, and then pushed along, right?
But you don't need that, I guess. Or?
It depends on what you're doing, right? A typical user probably not. A gamer, I mean, worst thing that happens, they lose their game or they lose their computer. So, but for you all, right, you're in the Navy, right? You don't want the Admiral's computer going down, the CO's computer going down, right? So you would definitely not be doing that because that goes against everything we're learning in here, right? And you wouldn't advise that to customers. Does that make sense for you, Grace? Okay. Now I'm sure your roommate probably thinks he's cool and whatever, but we wouldn't recommend that in our profession. Easy, Dick? All right, moving on. Let's see what we know. The steps to install an adapter card. Give you a second to read. All right, what is step 1? Find an empty expansion slot and remove the small metal cover. What is step 2? Find the adapter card to the appropriate slot on the motherboard. And 3. Press down gently on the adapter card until the card is fully seated. And that's what we call installing something, right? Is seating it, right? And you may hear the term, or you will hear the term, reseat, right? That means uninstall and then install it again. Seat. And step 4 is secure the adapter card mounting bracket to the case with the appropriate screw. Yeah. Next, we've got selecting additional storage. So here we have different storage for different things. Let's scroll down to the pictures. Let's see, this is an SD card. Let's scroll back up. Up more. SD stands for Secure Digital. Right, what have you used SD cards for? Cameras, right? That's what we're using in these cameras. Now, you have micro SD, which is a smaller version, and you have mini SDD as well. So here's micro SD.
In your phone.
In your phones, right? In fact, this is what a lot of cameras are using too. And then we have a mini SD, right? And compact flash. Legacy, yeah. Do you remember what does anyone remember what this was used for or in?
Digital games.
Just older cameras and games, etc. We also have memory stick. Who remembers what memory stick is used for? What company?
PlayStation.
PlayStation.
Sony.
It was owned by Sony, right? So that's Sony's proprietary memory. Now, when I say proprietary, does anyone know what proprietary means? Right here. Not publicly available. Now, of course, you can go out into public and you could buy a memory stick, right? But that company, Sony, they own the definition, right, and how it's distributed, etc. They own all of it. Versus like something else, right? Like SD. Any company can make SD cards, make it compatible. They don't have to pay licensing to that specific company. And you have XD, also used for pictures, etc. Questions, comments, concerns?
Of course.
This is money.
What does XD stand for then?
What does XD stand for?
Yeah.
Picture card. Let's scroll up. What does it stand for? XD, X-ray delta, picture card.
So
Why?
stand
I don't
for
know.
picture card? Okay.
All right, moving on. Here we have a media reader. Probably not what you're used to, right? Because we probably use more laptops, and you probably just have an accessory that takes it. Over here, this is for desktops, right? So your computer that you're building, upgrading, etc., may not have the capability to have an SD card, XD, compact flash, memory, whatever it is, right? So this is what it looks like, right? That you can add that capability to the computer. Moving on. External storage. What do we call this right here?
Security risk.
The security risk. I like that, right? We'll talk more about that in security. Thumb drive, USB drive. What type of storage does this use? Flash-based. Very good, right? The speed of this can differ, the capacity, etc. Moving on. You also have not just thumb drives, but you've got external hard drives that you can do that connect with Thunderbolt, USB-C, etc. Right? So it's what are your requirements? Let's see what we know. Which one of these is an older format but still used in cameras because of the high speed and capacity? Compact flash. All right, let's go with compact flash. All right, what is the smallest of the SD card formats commonly used in smartphones and tablets? Micro SD. That's what you said, right? Medium-sized SD developed for mobile phones. Okay. Oh. And what's a proprietary flash memory used for cameras, MP3 players?
He just said Sony proprietary, whatever. It's memory stick.
All right, let's put memory stick and let's see. Hit submit. Hit submit. Hit close, and then let's hit nothing. Got it. All right, and now let's watch this video here.
Hello everyone, this is our Install the Power Connector video. This is going to be a two-part video. The first part, we're going to install the power connectors on the motherboard. Step 1, we need to align our 24-pin connector with the socket on the motherboard. There's our socket, and here's our 24-pin connector. But step 1, aligning it means we need this clip to connect on the outside of the connector. So we can go ahead and we can align it with that connector. Now that it's aligned, step 2, we're going to gently press down on the connector until that clip locks into place.
Never that easy.
As we press down, you hear it click into place. Step 3, we need to align our 4-pin power connector for auxiliary power on the motherboard, which we'll see here also has a clip, with its corresponding connector on the motherboard. To align it, I'll just drop it in on top. And then, step 4, we're going to gently press down on that connector until it clicks into place. And now it clicked into place. Step 5, we need to take our CPU fan with its power connector right here. And we need to align this correctly, which you'll see a little slot here. You align that correctly with the actual CPU fan slot on the motherboard, which is right here. Step 6, we're going to gently press down on it and put it in place. It doesn't click, it just slides in, and we are done.
All right, let's see what we know. Scroll down a little bit more. Unclick that. Now click it up, scroll up. Now click. All right, what kind of connector is this? Molex, very good. The next one is auxiliary. Scroll down. The one on the left is, which has how many pins? 2024. And finally, the one on the right, of course, is very good. All right, another video, part 2.
Hello everyone. Welcome to our Install the Data Connector video. First, we want to take a look at our motherboard and find those SATA data connectors. They're down here. I've got 4 of them. Also, on my solid state hard drive, I've got the SATA power connector that we installed previously, but I removed it so we can see that SATA data connector, which is the smaller of the two on this side. So to get started, step 1, we need to align our SATA data cable, and it's notched to fit exactly down below. So we'll align it. And then after it's aligned, we can just gently push it in, and it will click into place. Step 2, we'll take our right angle SATA data cable here, and we're going to connect it to its corresponding connector on our hard drive. So we line it up.
Go ahead and pause. All right, notice how this cable has a 90-degree bend in it, right? Now, the cables that you've probably used, right, just go straight, right? But what happens to them as you bend them, etc., over time? Shortages, they stop working, they break, etc., right? So when we install the back cover over this computer, naturally that cable, right, is going to bend, right, over time. We don't want that to happen. So that 90-degree bend, right, when we go to the lab, I'll show you, right, which end needs to be at that 90-degree bend. Easy day?
Yeah. Clicks into place. Awesome. Thank you for watching our Connecting the Data Cable
video. Awesome indeed. All right, do I want to take a quick break or finish this chapter?
Finish.
Finish. All right, another video.
Hello everyone. Here we get to install front panel connectors. This is going to include audio connectors, as well as power switch, reset switch, hard drive activity lights. So to get started, we're going to use a different board just because the other board was more proprietary for a specific vendor. This will be better. To start it off, what we're going to see here is that down in the left corner, we'll zoom in on this in a little bit, we're going to have our front panel audio. And down in the bottom right corner, we're going to have our front panel connectors. So first, we're going to take a look at the front panel audio. So we have a zoomed in view of the front panel pins for our audio connector. And what you can see here is that we have 9 pins. It looks like one of them is missing. It's not missing, that's just because it's a keyed slot. If we take a look at the actual connector that's coming off of the front panel that we're going to plug in, it's this. This is an HD audio connector. And the HD audio connector, if we take a look at the actual holes, look at that. It's got that same keyed format. We've got that one that's going to be missing, and you know, the orientation for the motherboard. So all we need to do is slide this back onto those pins, and we'll have this up and running. So we've got our audio connector connected to our motherboard, and now we're going to move over to the front panel. So let's take a closer look at the front panel connectors on the motherboard. Here they are at the bottom right corner. What we'll see here is power LED, as well as hard drive LED, power switch, speaker, which is not your normal speaker, that's your errors and think BIOS and boot up issues, and a reset switch. What we need to do is take these connectors that are coming off of the front panel of our tower, and we need to hook them accordingly. Well, how do you know what goes where and what orientation? That's where you can select your manual. Bing, my manual is here. So you can see my diagram for how I need to connect these, and that's what we're going to do next. So what we'll do first is we're going to take the power LEDs, and that's going to be these two right here. And we'll take these power LEDs and we'll put them in the correct orientation. In order a picture, the positive one is going to go on the left to this pin, and the negative one will go here on the next pin over on the right. So I'll do that. And And what you'll notice is there is a gap between those two, and that's okay. That's a blank slot. Again, it's keyed. Next, what we want to do is go ahead and do the power switch. That power switch is hiding underneath here. There we go. This is the power switch. And the power switch is going to go right here where you see the power switch one, PWR, SW. Same thing for this. We don't have to worry about a positive, negative. We just need to drop this thing on that power switch. Power switch is installed. Next, we're going to do the reset. So we'll find the reset switch, which is this one right here. And reset needs to go on these two, as it shows in our diagram. The reset switch is now installed. And lastly, we're going to set up and do the hard drive LED. Hard drive LED, according to our diagram, is the bottom left corner. And our front panel connectors are now installed. So it's all installed. That's awesome. If we had any USB connectors, we'd pop them in and plug them straight into these keyed USB ports. It would be fine for those as well. My system does not have those for this motherboard and this case that I'm utilizing, so we don't have to drop those in. Now, take care and practice putting these connectors on, and make sure you take the time to find the manual so you know how to do it properly. You're one step closer to being an IT professional and doing one of the hardest parts of hooking up a motherboard inside of a computer case.
So of course, right, our case is a part of the computer, but if we didn't connect that to the motherboard, it wouldn't be really connected to the computer and do anything. So that's what all of those do when we saw the different switches. So we can see these here if we scroll down a little bit. Those are all those cables that he used. And if we click the next tab, we can see these system, the connectors here. Scrolling down some more, all of those. Now pin 1, here, now there's a triangle like we drew up on the board before. And that picture really doesn't show it very well. I'll draw a triangle even though I assume we know what it looks like. And now a triangle indicates to us what? Pin 1. Easy day? All right, and we can see the other tab for the other connectors as well. That's where your pin 1 location is there. Easy day? All right, let's keep going down. USB connectors, we've seen these multiple times as well. For the front USB connectors on your case, to connect those to the motherboard, right? That's where they're going to go on the board. And then here are the internal USB cables, right? That's where it's going to connect from on the bottom of the screen. That's coming from the case. And then the top of that screen image is where it's going to plug into the motherboard. Easy day? All right, moving on. We've talked about all of these, right, in that video. The power button, the reset button, the drive activity, LED, the USB, etc. And most likely you'll just have to look at your motherboard or the diagram for your specific motherboard because they are different. Let's see what we know. Almost done, everybody. What remains lit when the computer is on and often blinks when the computer is in sleep mode? Oh, too easy. What remains lit or blinks when the system is reading or writing data? Connects ports for jacks on the outside to connect microphones or external equipment such as signal processors, mixing boards, and instruments. I heard USB, I heard audio. What do we want?
Audio.
Audio, all right, we'll go with audio. What turns the computer on or off? Power button. What often consists of 9 or 10 pins arranged in 2 rows, but can also have 4 or 5 pins or individual groups of 4 or 5 pins. I'm hearing USB. USB? USB? Next. Used to audibly indicate the computer's status. If there's a hardware problem or series of diagnostic beeps, issues to indicate the problem. System speakers. We'll talk more about that in later chapters when we get into BIOS. What restarts the computer without turning it off? Reset button. We want to change anything? All right, hit submit.
Too late.
Very good. Go ahead and play that video.
Hello everyone. In this video we're going to reassemble our case, and then we're going to install our external cables. To get started, we have the front of our tower here, and we'll put on our front cover. However, the front cover just has these locking clips on the side, so we just need to line it up. And all you do is push them to the corners. And now, the front case is locked. We've got our USB ports, our headphone, and our mic port. Also in the front here, we also have our DVD disc drive that we installed. And turn this on its face. And now we can do our external cables. So for this part, I'll take off my anesthetic wrist strap. I can take my power cord. I can just slide the plug in here. And you shouldn't have to force any one of these cables as you install the cables to the back of your tower. I got a USB for my keyboard. These you do have to align and take a close look regarding how you need to align it. You'll see the correct end to slide in. And they have another USB. So this is my keyboard mouse combo. Again, we'll take a look at the alignment of the USB. Plug it in. Also at this time, I have my graphics cable. For me, I have a DVI connection. The DVI is going to go to my white port here, my graphics card we have installed. So I'll plug that in. And we've got 2 screws on that. We can just easily screw it until it's snug. You don't need to over tighten these. It's not going to fall out. Lastly, I have an audio cable and I have my network jack. Plug in my network jack to my Ethernet port. And my audio cable is green for my speakers out. I'll plug that in my green speaker out port. Our external cables are installed. Last thing, we take a look at the side. It's still open. We need to close it off with the cover. With the cover, it's just going to slide on. You can see the slots here along the top that we're going to lock it into. Just going to rest it in. Shift it and feel it slide into place. And then there should be no force really needed here. Just slowly slide it forward. Then I have my locking screw. So now I can just close that by hand. And then I can give it a little bit of a snug tighten. And again, you don't need to over tighten that. And now we're done. Our case is put back together. It is ready to go. Thank you for watching our video.
All right, one more quiz. Let's check our understanding. Top left photo.
USB.
What is that? USB. Look at that. Finishing strong. What's that? Power. This is mouse. What else is it for? Keyboard. This cable is not hot swappable. And finally, the bottom right is monitor. Specifically, that's a DVI. All right, are there any questions? Are there any questions on chapter 2?